All right, let us continue with the details of the lesson 1, the Java overview lesson, where we will be discussing with starting with brief history of Java. So, what actually Java is and how Java was developed, we will have a brief look. So, Java is actually developed at Sun Microsystems. Sun Microsystems was actually started by a small student group who were actually studying at the Stanford University. This group of students, they wanted to develop a common remote control which can control all the electronic devices. Say your AC, television, and any device which can be controlled by by a remote control. They want to implement a common remote control for all the electronic devices. That was the actual reason or the initial reason that they want to look for a solution using which or because of which they started the concept of Java language. So Java and the next point I want to mention is Java language was actually a project initially started in the 1991 year by the small group which I mentioned by James Gosling, Mike Sheridan, Patrick Norton. These were the main people. There's a team behind it. All right. So when coming to the name of Java language, there was an oak tree which was outside the James Gosling's office. So initially, the software that they were developing or the language that they were developing, it was called Oak. But they came to know later that there was already a language with the name called Oak, and they would be, you know, coming across some troubles if they name the language as Oak because somebody already has that name. So they changed it to some other name called Green. The name was renamed as Green, and finally, or eventually, because their favorite Java coffee bean coffee bean is Java, so they named it as Java. Alright guys, that's the history behind Java. Alright, now let's look at the Java's released versions till now. We have almost 10 released versions till date for Java. The first version of Java was actually released in 1995 and it was named as JDK Alpha and Beta. JDK stands for the Java Development Kit. The second version we had was the JDK 1.0, which was released on 23rd January 1996. We had the next version JDK 1.1, which was released on 19th February 1997. The JDK or the Java Development Kit was later renamed as J2SE, the Java 2 Standard Edition, with the version number as 1.2, released on 8th December 1998. The name was still retained with J2SE and the version is 1.3 this time, which was released on 8th May 2000 year. And the next version, subsequent version was on J2SE 1.4 on 6th February 2002. The best version out of the all the initial versions you can say is the J2SE 5.0, which was released on 30th September 2004. Then we had the Java SE 6. It was renamed as Java SE, Java Standard Edition instead of Java 2 Standard Edition. And from the version 6 onwards, or the Java 1.6 version onwards, it is called Java SE6, released on 11th December 2006. And we have Java 7 or the Java Standard Edition 7, released on 28th July 2011, and the latest one that we have right now is Java Standard Edition 8, which was released on 18th March 2014. I'll give you a brief overview of what were the features that we have, or at least the major features that we have got with each of the Java or the JDK kit versions. Now, Okay, if I define the major features of Java or the JDK in different versions, I can only consider four things till now, and the latest one which is going to be released as Java 9. I'd give you the basic information on these versions. In the JDK version 1.1, there was a feature called RMI, the remote method invocation, using which the method which is invoked by one Java virtual machine can be used by the another Java virtual machine. What is actually Java virtual machine and how the methods are invoked, we'll not go to that point right now, but we will definitely get to know what is a Java virtual machine in the subsequent slides. Alright, so the next version, Java 1.2 or the J2SE 1.2, had the unique feature called the collection classes. Collection classes include the list, set, array list, all these classes which store variables or values, group of values I can say, in one single variable. We will get to know in detail about the collection classes also in the subsequent lessons. Then in the Java version 5.0 or the J2SE 5.0, there are two new features called enumerations, or simply put in short as enums, and there is a concept called generics which can create a method which takes input as any type of data type. We may not be discussing generics in detail because in core Java we would not be requiring generics to be learned. However, you can have a quick look at what generics is once we complete with the object-oriented concepts of Java in the lessons. Alright, and in Java SE 8 or the Java Standard Edition 8, we have the new feature called Lambda expressions, method references, and streams, input streams, output streams, specific details in the Java SE or the Java Standard Edition 8. And in the Java Standard Edition 9, which is going to be released very soon, there are some proposed features which they want to add. Those are support for multi-gigabyte heaps. What is a heap and all, we will just get to know during garbage collection topic. Then to have a better native code integration, how to self-tune the Java virtual machine, which means we will be able to tune the Java virtual machine automatically, to make Java into a module system, to introduce money and currency type API in Java, to introduce something like a PowerShell of Windows or Unix shell scripting for Java. Also they want to introduce something called a Java shell, and there is some concept called parallelization which they want to make it automatic in Java Standard Edition 9. These are the proposed features of Java Standard Edition 9 which was due to release but has not yet. Coming to the next one, the types or profiles of Java APIs. What is the API? API in short, or the abbreviation of API is Application Programming Interface, which is a set of classes or a collection of classes is what we can say. And Java has actually evolved into three different sets of APIs or three different sets of libraries, which are also called profiles by different people. Those three different sets of profiles or libraries are the Java Standard Edition or the Java SE that we have seen till now, which supports desktop and standalone server applications. The second profile is the Java Enterprise Edition or the Java EE, which you can see the denotation or notation for the Java Enterprise Edition, usually seen as Java EE in the official namings, which is used for developing and executing Java components that run embedded in a Java server. The third profile is called Java Micro Edition or Java ME, which is used for developing and executing the Java applications on mobile phones and embedded devices. Coming back to the definition of Java, where Java can be defined or Java can be considered from an initial programmer's perspective or a basic or a novice programmer's perspective. I can define it as a general purpose programming language which is object oriented and which is mostly considered to be evolved from the C and C++ languages. However, Java is not just a programming language, it is also a platform simultaneously. Platform in literal sense means that the hardware or software environment in which the programs can be executed. Java has its own software based platform called the JVM, which we spoke a few seconds ago, or the Java virtual machine to execute Java programs, which will be seen in the next topics. As I already mentioned, Java is not only a language but also a technology. So what actually Java technology consists of? Java is a programming language. It is also a development environment. It has a deployment environment also. As well, there is an application environment in Java. So what each of these things does in the Java technology? When you have the Java programming language, using the programming language, we can create all kinds of applications as we can do with any other conventional programming languages that we see around. So you can do all manipulations and application development with Java programming language. So what does the development environment do? It provides a large suite of tools for us. We have compilers, we have interpreters, we have document generators, we have class file packaging tools, and so on. There are so many other things that it contains. Those are the major ones that I want to describe. Then what is the Java application environment? Java application environment provides standalone programs and it do not require any web browser for the execution of the application. The Java standard edition which I have mentioned will usually do or will usually work for the Java application environment. And the Java application environment contains three things. The first one is applications, which are standalone programs that can run on a single or a standalone computer. We have something called an applet. The applets, these are the programs that run on a web browser. Applet viewer is provided in Java so that it ensures the programs are run even without a web browser also. There is one more component called servlets. These are the programs that run on the server side. So Java application environment contains these three things: applications, applets, and servlets. Coming to the deployment environment, Java has the following main environments: JRE by Java 2 SDK containing technology packages like language classes, GUI component classes, collections API, etc. And for web browsers which supply interpreter and runtime environment is also part of the deployment environment of Java. Coming to the features of Java, Java's features are: it is simple and object oriented, highly secure, neutral in architecture, has very high performance, it is portable for us to use, it has threading or multi-threading, so it is threaded and it is also dynamic, it is dynamically linked, and it has no pointers. Coming to the details of each of the features, why Java is simple is, it is simple because it is free from pointers concept, which is actually complicated. It has a rich set of APIs which will make us use a lot of inbuilt classes and methods with lots of packages to choose from. It has a inbuilt garbage collection process using which all the unreferenced memory will be cleared, which we will look at in the further coming topics. It contains a very user-friendly syntax using which we can develop any applications easily. Java is also object oriented. So like any other object oriented language, Java also uses or takes the features of any object oriented language, the four main principles of object oriented language called abstraction, encapsulation, polymorphism and inheritance. So the next point in the feature is highly secure. Java is highly secure because of the different features that it has, like can be servlets, or it can be the abstraction concept, or anything that you look at in a broader perspective. Java provides a highly secure platform. When coming to the neutral architecture or architecture neutral concept, Java was actually designed to support applications on different networks. So in general, networks are composed of a variety of systems, and they also will have different CPUs or the processing units and operating systems and different architectures also. So to enable a Java application to execute anywhere on any network, the compiler will generate an architecture neutral file which will contain all the machine readable code, or simply put, the compiler will generate an architecture neutral object file format. Okay, the compiled code is executable on any number of processors if you have a JRE on that system. Java is also high in performance when compared with many other procedural languages because it's object oriented. It may be low in performance when compared with the very new technologies or languages that you look at, but comparing with the other features that other languages offer with Java, the performance of Java can be definitely said to be high performance. Okay, let's come to the portability point. How Java is portable is Java contains something called a bytecode, which the concept of bytecode we will look at in a few in another few points afterwards. So Java generates something called a bytecode, because of which it becomes platform independent. The architecture itself is given to Java so that it can be carried forward and used or executed on any type of platform. We will discuss about it in more in the coming slides or in the coming points. Alright. And coming to the point of threaded and dynamic, Java is implementing a feature called multi-threading concept, using which different threads can be executed simultaneously. As you see in a daily life software, when you open in a system, you can also listen to music. At the same time, you can fill a form and submit. So this can happen for an operating system because it has the multi-threading concept. Similarly, in an application, in the same application, you can also upload a file. At the same time, you can fill a form. Or if I want to simply put it, I'll take the example of a Gmail application where you will upload your files or attachments to send to somebody, and simultaneously you can compose your mail while the files are getting uploaded. Uploading is a different activity and composing is a different activity, but those two activities are being done as a multi-threading concept application in the Gmail. Now for the feature of dynamically linked, if I have to give an example, when any programming language like say C program is compiled, the compiler will generate something called an object code. Object code is something which is readable by the CPU or the processor. So once you the object code is generated, the compiler will invoke something called a linker. One of the main tasks for a linker is that the code of library functions, something like printing, scanning, mathematical functions like square root, examples, all of those things are usually be part of some library functions. Those will be made available by linker during the execution. So a linker can accomplish this task of getting all the library functions to the executable program in two ways, either by copying the code, the entire code of the library function into the machine readable object code, or by making some arrangement so that the complete code of the library functions is not entirely copied, but it can be made available through some other way at the runtime. Okay, so the first way is to completely copy the library function code into the executable file during the runtime, or to make that code available instead of copying directly at the runtime. Static linking is the way the linker will copy all the code of the library functions to the executable file. Dynamically linking is that during runtime the code is made available. Instead of copying the entire code, it will just have the code at the other place, but the code is made available so that the binary file or the object code file can be run during the runtime. Alright, this is usually happening, or this usually happens when the program is run and the libraries will be in the memory. Examples of dynamic libraries, if you look at, are .dll files in Windows, .so files in Linux. So those were the features of Java language in short, which I can mention. Now coming to the concept of comparison between Java and other programming languages. How Java programming language is different from other programming language, if you look at in the purview of memory management, there is a clear-cut difference between the Java programming language and other programming languages. In languages like C or C++, the code writer is responsible for deallocating the memory. Once the memory is allocated for any variable or a method or anything, there is something called a code writer which is responsible for deallocating the memory. Whereas in Java, the Java itself automatically allocates and deallocates the memory so that the programs are not burdened with the task, which means the programmer don't need to remember and write code for allocating and deallocating the memory. Whereas in other programming languages, as we have seen, the coder has to write the code for allocating and deallocating the memory. Allocation will happen when a variable is usually created, but deallocation has to be done by the programmer. It is very difficult for a programmer to understand the implication of where and when the deallocation should happen, and it is not always possible to understand and remember where the memory should be released. So it's a difficult task in other programming languages to deallocate the memory. Whereas in Java, the deallocation of the memory will be automatically taken care by the memory management process. Also, in other programming languages, we have the memory leaks because of the problem that we are not able to manage the deallocation of memory. So there can be crash because there is no memory that will be left. This process is called the memory leaks. Or in short, when I put it in short, programs that do not deallocate memory can crash as no memory will be left, and that is called the memory leak. It is highly unpractical or not possible in Java that to have memory leaks, because memory management is very easily done using the automatic garbage collection mechanism. This feature is inbuilt in Java. Alright, let us now look at the process of garbage collection. What is a garbage in Java? Garbage is something that is not actually being used right now, or which may not be used in the coming few minutes of time by the program. So whatever Java object that we create will be residing in an area called heap. We spoke about heap a few minutes ago. Heap is the place where the Java objects reside, and when the heap is full, the garbage is collected, and during the garbage collection, the objects which are no longer are used will be cleared, and they will make space for the new objects. Because the objects are no longer being used, we don't need them anymore, so there will be marcation for those objects and they will be cleared. And if an object is in use or it is already being referred, means that some part of the program is still maintaining a pointer. Okay, these pointers I'm talking about are not the C language pointer or anything. The pointers are internally used. We don't need to write any pointers. So when you talk about an in-use object or the reference object, there is a pointer to the referenced object which is maintained by the Java internally. So whenever you have an unused object or an unreferenced object which is no longer referenced by any program, the memory used by the unreferenced object will be reclaimed. How is it done? There are 3 steps. The first one is marking, second one is called normal deletion, third one is called deletion with compacting. How do you reclaim memory? You can see the flow where we have the marking, normal deletion, deletion with compacting. How do you do the marking, or how Java does the marking when doing the garbage collection? Initially it will identify, or the garbage collector will identify pieces of memory that are in use and which are not in use. So that will be done by garbage collector and it is called marking. The objects which are all the objects are scanned for this purpose in the marking phase, and they'll be determined which one is being used and which one is not being used. Actually speaking, this is a very time consuming process, because all the objects that are currently being used and which are in the memory right now have to be scanned. So once the marking process is done, there is a clear-cut differentiation or marking about which object is alive or which object is being referenced right now. What are the different unreferenced objects or unused objects, and what is the memory space that is available between these objects, or what is the memory space available for any further object creation. So once the marking process is done, the unreferenced objects will be removed and all the referenced objects only will be retained in the memory space. Because the referenced objects were being pointed or pointers were being maintained by the Java environment, all the unreferenced objects only will be cleared and the referenced objects will be still retained. And because of the unreferenced objects are deleted, there is a free space available now, more of the free space available now. The memory allocator will hold references to each of the blocks of the free space that is freed because of the normal deletion, and this free space can be allocated and will be allocated to any new object that will be created during the runtime. The next step is deletion with compacting. So once all the unreferenced objects are deleted and there is a space allocation available for the new objects, and when the deletion happens for the unreferenced objects, there is a memory space available which is which can be given for the new objects, there is a compaction that can be done so that the new objects whichever will be allocated with some memory can also provide more space because of the already deleted ones. If you take the case of zipping any files, whatever file, say for example we have a 1 MB file, when you make it into a zip file, it becomes less than 1 MB, definitely less than 1 MB, maybe some 100 KB less or whatever may be. How does it happen? Because that will be compacted in the memory. Similarly, here deletion with compacting happens for the unreferenced objects, making way for the new object creation, also along with compacting, giving some more memory space availability.